Alrighty, 5.5, simplify algebraic expressions. So we've already talked about these vocab words, right? We did in 5.1 and then we discussed them again yesterday. But we've got terms, constants, and then we've got like terms. So a constant, so what's in orange there, is the number that is not attached to the variable. If you have two terms, and one is 4x and the other is positive 2. The term 4x can change, right? The value of that term can change based on the value of x. If I say x is 2, well then the value of that entire term is 8. If I say x is 4, then the value of the term ends up being 16. However, the second term, this positive 2, that's just going to stay constant. It's not going to change no matter what until you simplify the expression, right? So the constant stays the same. That's what constant means, right? We've got three terms here because we've got three kind of sets of numbers or variables separated by addition or subtraction. In this case, just addition. The like terms are negative 4x and x because they have the same variable to the same power. Keep in mind, same power. So if I had x squared, then negative 4x and x squared would no longer be like terms. Like terms have to have the same variable, yes, but also to the same power. Alrighty. Let's go ahead. We are labeling today, before we start simplifying, we are identifying and labeling the terms, like terms, coefficients, and remember the coefficient is the number that's attached to the variable, and the constants. So in this expression, example 1, we've got 6n minus 7n minus 4 plus n. If you want to get out your colors or your highlighters, go ahead and do that now. Let's look at the terms. So I'm going to highlight my terms in a light pink. So my first term is 6n. My second term, the most common mistake is for us to say 7n, but don't forget, include the negative with it. So it's really negative 7n. Same with this 4. It's not just 4, it's negative 4. And then here, n is just positive n, so you can just write n. So those are our four terms. So here we would write 6n, negative 7n, negative 4, and n. We're just labeling the terms. Alrighty, let's look at our coefficients. So our coefficients, the numbers that are attached to the variable. Whoops, just deleted that in. The number that is attached to the variable. I'm erasing everything. 6n, 7n, plus n. Okay, so the number that's attached to the first variable is 6. So that's our coefficient. Now, the coefficient that's attached to the second variable, keep in mind it's not just 7, it's negative 7. So negative 7 is the second coefficient. Now, the coefficient that is attached to this last variable, positive n, some would forget and say that there are no coefficients there. However, automatically, how many n's is that if it just says n? There's 1, right? There's always an invisible coefficient if it's just a variable. The invisible coefficient is 1. Now that positive sign or negative sign in front of the n is going to tell you whether the coefficient is positive or negative 1. In this case, since it's plus n, our coefficient is positive 1. Any variable, no matter if it has the number in front or not, does have a coefficient. It's 1. All right, our constants. Our constant is this negative 4. So keep in mind it's not just 4, it's that negative 4. And then our like terms. So like terms, we've got same variable to the same power. So looks like all of our variables are like terms. Now, constants, if there is more than one constant, that will also be a like term with another constant. So our like terms are, let's see, keep the green, 6n, negative 7n, and positive n. Alrighty, let's scroll down to example 2. 9y minus 4 minus 11y plus 7. Our like terms are, we've got 9y, and then we've got negative 11y. Keep in mind it's not just 11y, it's negative 11y. So 9y, negative 11y. Now, we have constants here as well. Can't really see that 4. The constant, negative 4, and the constant, positive 7, since they don't have a variable, then that they automatically are like terms as well. So we've got 2 sets of like terms. So negative 4 and positive 7. And then the terms, actually, we've already listed them out because there are 4 terms. All of them happen to have a like term. So it's just going to be 9y, negative 4, negative 11y, and 7, positive 7. And that's, oh, maybe I shouldn't use the same color pink because then it's going to blend together. These are our 4 terms. Our coefficient, the number that is attached to the variable. We've got 9, 9 is attached to the first y, and then we've got negative 11, because negative 11 is attached to the second y. Our constants, the numbers that are not attached to the variables, we've got negative 4 and 7. Alrighty. I'm going to have you guys do this one, and I'll have everybody right now type in the terms to the chat box. Type in the terms. So the terms here, we've got 3x, 2, negative 10, and negative 3x. Alrighty, type in the like terms to the chat box and separate, if there are 2 sets, separate it with an and. Alright, these like terms, we've got the 3x and this negative 3x. And then we've got constants as well, right? This positive 2 and this negative 10. So using your colors, I definitely think labeling those would be beneficial. So 3x and, let's see, whoopsie, 3x and negative 3x and 2, negative 10. Alrighty, our coefficients, the numbers that are attached to the variable, type those in. We've got 3 and negative 3. And our constants, we've got 2 and negative 10. Alrighty. Let's start simplifying these now that we've labeled our terms, like terms, coefficients, and all of that. So an algebraic expression is in simplest form if it has no like terms and no parentheses. So for instance, yesterday with our distributive property, we were simplifying the algebraic expression because we were getting rid of those parentheses. Alrighty, so let's simplify. Write 4y plus y in simplest form. We've got 4 y's, we add another y, we get 5y. Alrighty, example 5. 7x minus 2 minus 7x plus 6. Now, to simplify this is where I want you to use colors. We are not going to rewrite this. You will see that some people will. However, If you use colors, and that'll start getting you won't always have to use colors, but breaking it down today will be helpful. We often make mistakes with our positives and negatives, which we already are familiar with, right? We made a lot of mistakes yesterday too with our positive and negatives when we were distributing what was outside of the parentheses to what was inside the parentheses. So let's circle our like terms or highlight our like terms in whatever color. I'm going to highlight them, so I'll use this light blue. So I've got 7x and I've got negative 7x. And then my other set of like terms, I've got negative 2. I've got positive 6. Alrighty, so in this case, to simplify, we are going to take this 7x and make it, you don't necessarily have to write what I'm about to write, okay? I'm just going to write what I'm explaining. 7x minus 7x, right? We just make another expression using those like terms. So 7x minus 7x. Well, you've got 7x's, right? And you're taking away 7x's. So you have 0x's. If you want to write that down just to show yourself that you've taken care of that, you're welcome to. Now, keep in mind, if we have 0x's, we're not going to write it down because you have nothing. Alrighty, and then we've got, so I'm going to erase this. You've got negative 2 plus 6. So if you need to use your tug chart, go ahead, but negative 2 plus 6 gives us positive 4. So we've now taken care of our like terms that were in blue and our like terms that were in green. Since we don't need to write down 0x, we can erase that. And since we don't have to have plus 4 to show that it's positive 4, our simplest form is 4. And that's our expression written in simplest form because that 7x minus 7x canceled out. All right, let's do another one. Let's go ahead and do these got it. Page 389, C through E. I'm going to pause the video and then I will go over those got it's in just a second after you get through them. Give me just a second. Okay, so I paused that video. Let's go ahead and continue these got it's. Page 389, C. Whoop, I'm still in highlighter. Alrighty, we had 4z minus z. That gave us 3z. D. We had 6 minus 3n plus 3n. This 3n, negative 3n, plus 3n is actually going to give us 0n, right? So we don't have to write that, and our simplified expression would just be 6. And E, we have 2g minus 3 plus 11 minus 8g. Our like terms, we've got 2g, we've got negative 8g. So 2g minus 8g is going to give us negative 6g. Then we've got negative 3, let me change my color here, negative 3 plus 11. Negative 3 plus 11, you're again welcome to use your tug chart, but that will give us positive 8. Now, here in this case, you could have written this expression two ways. You could have done 8 minus 6g, so that negative g is still negative, and that 8 is still positive. Either way, it does not matter. It's truly the same expression. I'll try to get this without erasing everything else. Oh, and I did. Oh, and I did again. Alright, plus 8. 8. So either way, totally fine. Alrighty, let's go ahead and let's do one more example before we continue and work on some independent practice. Example 6. The cost of a jacket, which is J, after a 5% markup can be represented as J plus 0.05 J. Simplify the expression, then determine the total cost of the jacket after the markup if the original price is $35. So if we've got J plus 0.05 J. This one's a little funky because we have not factored expressions yet. That was a 6th grade skill. That is one of the ones that we need to bridge. So actually, rather than, I'm going to make that a mini lesson for next week. And we'll come back to that because I want us to get started on homework. So let's go ahead and pause here, or after we get through homework, I'll do this mini lesson. Let's pause here and let's go ahead and get started on homework. Your homework is page 391, numbers 1 through 9. Now, let's see, number 7 is very similar to this example 6, so we're going to skip number 7 for now until I get through this mini lesson. Alrighty, so again, 391, numbers 1 through 9, skip 7. I'll pause this video and we'll go ahead and get started.